Finding the gradient. First, we're going to look at finding the gradient from a graph. Let's remember that the gradient equals rise over run. So if we have a look at the graph in the top left-hand corner, we can see that our run, we'll do our run first because it is the easiest. It goes from 1 on the y-axis, and we're going to go all the way over to 1 on the x-axis, so where that yellow line is. And we can see that that is one place, it's plus 1. Now if we have a look at our rise, we can see that it goes from here, where y equals 1, all the way up to y equals 3. So we've gone up 2 places. So our gradient equals, our run is 1 and our rise is 2. If you put that into your calculator, 2 over 1, you will see that the gradient will equal 2. So that is how we find the gradient of a line from a graph. Next, we're going to look at finding the gradient from a table. I have included the graph here, and you will see that it is the same graph as we had on the first slide. So I want to show you both processes and show you how we get the same answer. So this time we have the table, and we can see that our x values are -1, 0 and 1, and our y values are -1, 1 and 3. Now the gradient when you're doing it from a table equals change in y over change in x. Now if we have a look at our table, our change in x, we can see that from -1 to 0, that is a +1, and from 0 to 1, that is a +1. So our change in x is +1. If we have a look at our y, we can see that we go from -1 to 1, which is a change of +2, and then we go from 1 to 3, which is also a change of +2. In all linear relationships, the change between numbers in a table will always be the same. So we can see from the table that our change in y is +2. So when we look at the gradient, our change in y is 2 and our change in x is 1. So again, our gradient will equal 2. Okay, now I'm going to talk to you about that super formula that we've been talking about, y equals mx plus c. This formula is vital when it comes to linear relationships. So the first thing we're going to do is find the gradient, and you would remember that m equals the gradient. So to do that, we're going to use this table and do exactly what we did on the slide before. So our change in x from -1 to 0 is +1. From 0 to 1 is +1. And if we look at our change in y, from 4 to 1 is -3. And from 1 to -2 is -3. So our gradient will equal our change in y, you can see, is -3. And our change in x is 1. So our gradient, or m, will equal -3. Now if we put that -3 into our formula, y equals mx plus c, you will see that we have y equals -3x plus c. And from there, we choose a point in our table. So if we take our first point where x equals -1 and y equals 4, we can see that we put 4 in where y was and we put -1 in where x was. We have 4 equals -3 times -1 plus c. Let's do that multiplication of -3 times -1, which equals 3, and we'll have 4 equals 3 plus c. To get c on its own, we will minus 3 from both sides, and we end up with c equals 1. Okay, so now we know what c equals. We're using that super formula again, y equals mx plus c. We know what m equals, and we know what c equals. So our equation of our line will be y equals negative 3x plus 1.